relates to trinomials and factoring. Oops. So although I know it's not your favorite topic, we do need to cover it. So, this is a method of solving. We're still solving quadratic equations, which is what you were doing yesterday. We're just doing it with a different method today. And the first thing I want to remind you of is kind of our standard trinomial form. We worked with this a lot when we started factoring back in chapter 5. ax squared plus bx plus c is one of the forms that we used most of the time, where the a is a number, the b would be replaced by a number, and the c would also be a number. The x squared or the x would be the variables. It is often actually an x, but it could be any other letter, but remember quadratic means one of them is to the power of 2. We did a lot of factoring with this, and since we're solving equations, we're going to have it, of course, with an equal sign. Okay, so here's the thing. We did, and again, I'm going to remind you of another pattern that we had here back in, again, chapter 5, that one of the things we had when we did a perfect square binomial, and I'm just going to write these patterns down again, is we had the pattern a plus b squared or a minus b squared. Right, so notice we're still talking about squares a lot. We're using these exponents. And the pattern said, oh, this would be a squared plus 2ab plus b squared, and this one would be a squared minus 2ab plus b squared. This was a very common pattern. Remember, this is the one I'm trying to remind you of as we go through this chapter, the square of a binomial. And the idea with this was that both of these, the a and the b, the first and the third term, were perfect squares. What we're going to do is we're going to be trying to use this pattern and these formulas. What if it's not a perfect square? Can we still try to use this pattern to make it into a perfect square? So, first of all, let me just kind of show you the beginning of this. The first steps, and when it says complete the square, so the first, we'll start with a simpler beginning. Complete the square. And there will be a blank in the third position. So here's the idea, is we want to figure out what would be in that third position if this matched that pattern. Now, because it's a plus, let me just point out in the patterns that when it's a plus in the binomial, all signs are pluses. If it was a minus here, the first one is a minus, but the second one in front of the b squared is always a plus. So I look here and I see a plus right in the first one, so I know it's going to be a pattern with a plus. If this were going to match this pattern, what would go here? This is like my a plus b. So we can look at the first part, we can go, oh, okay, I know what that would be. If this is squared, what would it be here in the parentheses? What's being squared? What is being squared to get this? Kate? X, right? Now, what we don't have is the third piece, but we can use this middle piece to help figure it out. And I'm going to give you a little pattern to help figure out what goes in this third spot. Some of you might be able to see it already, and that's great. But I'm going to show you the pattern anyway, because as it gets harder, you need this pattern. First of all, let me just go back to this. Notice the a is whatever variable is by the x squared. The b, usually in the middle, but again, it could be out of order, in the middle with the plain variable, and then the c is where it's just a whole number. So that's the part we're needing to figure out. Here is the pattern for completing a square. The first thing we're going to do, and actually, let's see, I'm going to try to write these over to the side here. There's some steps. So the first step is to take our b value, and we're going to put it over 2. Actually, I take that back. We don't need a lot of steps. I was going to write out all the steps, but I think they go through it in the book with 4 steps. I don't think we need to go that specifically. And here's what you're going to do. You're going to take the b over 2, and you're going to square it. Okay? Now, let me get back to that. What's our b value in this example that I did? Vincent? 14. So the first thing we're going to do is we're going to take our 14 over 2. Then we square it. Okay, well, here's what you want to do. If this is something that will divide evenly, then we're just going to go ahead and divide it. I'll show you another example where it doesn't divide evenly in the next example. But since it does, let's just do the math. 14 divided by 2 is 7. 7 squared, 49. The answer to that goes right here in this spot. Because if you think about what we're doing, if this middle part, let me go back up here to the patterns, was 2 times A times B, well, it's like we're dividing by 2. We're taking out that 2. And then we're going, now we need to square it because, of course, this is the square of a binomial. So if x squared was the perfect square of x times x, now I know 49 is the perfect square of 7 times 7, which means that we have filled in that missing third spot to force this to be in this pattern of the square of a binomial, either one of these two. What we're trying to do is we're trying to force a trinomial to match this pattern. So the first ones you're going to have, it's just going to have an empty third spot. And all you have to do is do this. And that answer goes in your third spot. Once you have that, then you can go, hey, this factors down to this. Now this is not necessarily your answer to begin with. If it's one of these, I just want the answer that's in the blank. But I'm showing you hopefully why we're doing that, because then it would go to this square of a binomial. Let's do one more just with this step before we move on. Let's do one with a minus now. Now even if it's a minus in the front, it would still be a plus for the third piece, but what it would equal is the square of a binomial where it's got a minus between the A and the B, the first two terms. Okay, so in this case, again, I take my B value, right, using this little formula in green. What's my B for this example? Rebecca? Good, we're going to include the negative here because the B, we want that whole number that's being multiplied. Here we didn't need to include the plus for the 14, but we're going to go negative 9 over 2, that whole thing squared. Does negative 9 divide by 2 evenly? No, right? You guys are thinking it's a decimal, it's 4.5. We're not going to put a decimal in here. What we are going to do is just simplify this by squaring it. The square outside the parentheses just means we square both numbers. Negative 9 times negative 9 makes 81. 2 times 2 makes 4. So you can leave it as a fraction. You do need to square it, but just do it like this. We're not going to put a decimal in there. And now, let's just see if we can do this part. I have forced it to fit this pattern. X squared, of course, is the perfect square of x times x. Now the second part might seem hard, but guess what? You've already actually written down the answer. This is the perfect square of what? What did we square? Here it is right here. What did we square? Luke? Negative 9 over 2. You guys see what happened there? We go, this is the perfect square of what? Don't even think about it. Guess what? You just squared it. Here it is. We don't take the exponent. That's to get the squared version. What did we square? We just write it in. That's it. So instead of here, right, this was 7, and that 7 went there. We could also, though, look at 49 and get that 7. That one was a little simpler. So just keep it as a fraction, as an improper fraction, filling in that third spot. So the first thing you're going to do is a couple of these for practice, just filling in that third spot. That's the beginning of completing the square. What we're doing is we are making this a complete trinomial that fits the pattern square of a binomial. So you'll have a few like that to get warmed up on. Then, here's the real thing to solve. I'm going to try to give you just 2 examples of this. Solve x squared. Let me write this down. Solve. Because now we're going to have to get our answers. And remember, there's usually going to be 2 answers for a quadratic equation. Now, here's the thing, guys. Later in this chapter, you're going to get to choose how you want to solve one of these. Maybe you want to factor it. Maybe you want to do another method that I'm going to show you next week. Maybe you're going to like completing the square. We will, at the end of the chapter, be talking about what we're doing this whole chapter is solving quadratic equations. And what we're doing each day is a different method for it. And at the end, we're going to put them all together and you get to try to figure out which method works the best. So for today, we're going to solve all these by completing the square. The first thing I notice is, guess what? There's something in that C spot. Is 18 a perfect square? No. So you know what? I don't want it in that third spot because automatically it will not fit the pattern. Remember that the pattern says that this third spot has to be a perfect square, the square of whatever B is. And 18 is not a perfect square. So what we're going to do is we're going to take this third spot, I'm going to move that number over, always the third spot, the C value, and I'm going to leave a blank. I added 18 to both sides to keep it balanced, so now instead of 0 I have equals 18. What sign, according to the pattern, what sign should always be on the third term? It's always, Diego, it's always positive. Because even if it was a negative number, negative times negative makes a positive. Okay, now we need to do completing the square. This is basically what we had before, except before we didn't have an equals 18, but don't worry about that part. We fill in the third spot. How do we fill in the third spot? Always the same, always this pattern. So let's do it. I take my B. In this case, that's negative 3. I put it over 2. I square it. Okay, not going to divide evenly. So remember that all we do is we square it, and we write the squared answer in here. Negative 3 times negative 3 is 9. 2 times 2 is 4. Now, notice what I did here. This is a step, even I forget this step sometimes. So I want you somehow to mark something to highlight this. When we add 9/4. Now this one's going to be a little bit, the next one I'll do is actually going to be easier. I should have done the next one first. But this one's going to be a little hard just because it's fractions. We have to add fractions. That's all that's hard, is just that extra step. But notice what I did here. When I add something to the left side of the equation, what else do I always have to do? I'm adding a new number here. Leanna, what do I always have to do?
Add it to the right.
Yes, you have to add it to both sides. And this is the step, even I forget to do it sometimes. If you add, when you add this third spot in, you have to add the same amount. Otherwise you're changing the equation and you'll get the wrong answer. You're making it into a different equation. So just somehow, I tried to highlight it in yellow, somehow make yourself a little note that this step is crucial. Again, not only does it give you the wrong answer if you don't do it, but it's a step that's really easy to forget. Okay, now, we need to try to solve this. The good news is, on the left side, what we have done is we have pushed it into this pattern, the square of a binomial. X squared, the perfect square of x times x. 9/4, well, I already did it here. It's the perfect square of 3/2 times 3/2. So we just plug it in as a fraction. Now on the right side, maybe we want to go ahead and add this together. If you want to do that, we could turn this one into fourths. We could say this is 2 1/4, right? 9/4 is 2 1/4. 2 plus 18 makes 20. If we want to just keep it as a mixed number for now, 20 1/4, you could also have turned it into 81/4. That's another option there. So I apologize, the fraction one, I should have done this one second. The only thing that's tricky now at this point is just we have to work with fractions. So I'll show you one without a fraction next. This is the hardest one right here. Now, other than the fractions, this is kind of what you had yesterday. What we've done by pushing it into this square of a binomial pattern is now we take it and we write down the square, and now we can start to solve. How do I get rid of that power of 2? I take the square root of both sides. Now don't worry, this fraction is going to get easier in a second, I promise. X minus 3/2 equals, square root of 20 1/4. I don't even want to look at that, it hurts my brain. But look at what it looks like as an improper fraction. 4 times 20 is 80 plus 1 is 81. What if I had it as 81/4 and I took the square root of that? Oh, that doesn't hurt my brain. Those are perfect squares. So if you have a fraction, you're going to need to decide which one's easier to work with. I see this 81/4, oh my gosh, those are perfect squares. So when I take the square root of this side, I want to take it as 81/4. Okay, now I already took the square root here, so I'm going to leave that 81/4. Plus or minus 9 and 2. Square root of 81 is 9, square root of 4 is 2. Again, this one's a little trickier because of the fraction, but it won't get any harder than this. You just have to now remember how to add and subtract with fractions. So again, we choose the method that's easier, the perfect square improper fraction. Don't forget your plus and minus. My final step, add 3/2 to both sides. So now the idea here is by completing the square, by filling in that third spot with a perfect square, we can now do like we did yesterday, take the square root of both sides. Now, I know it's tricky because it's fractions, but they have the same denominator. So first I'm going to take positive 9 over 2. If it's positive 9 over 2 plus 3 over 2, I get 12 over 2, right? 9 plus 3 is 12. The denominator stays the same. One possible answer, 6. If it was negative 9 over 2, when the signs are different, I subtract. 9 minus 3 is 6, so 6 over 2 or 3. There are my two answers. I will try not to give you too many with fractions. Let me do one more without a fraction. Questions? Going back? Let me do the one that's a little easier without a fraction. Yes, Leanna, which part?
Get the 81
So that was, and I didn't show it here, I was going quickly with the fractions. How did I get this? What if I was adding these two? So remember when we're adding fractions, let me show you 18 over 1 plus 9/4. I can't add them together like this. I would need to turn 18 into something with a denominator of 4. So I go times 4 and times 4, and it makes 72/4. I took that, and then you'd add these two together. Right now I can add the fractions. I took a little shortcut by just giving you guys the answer, but I'm glad you asked because I should have mentioned that I was taking a shortcut there. Right, so where did this come from? Well, getting a common denominator and adding those two pieces together. The easier way, what I was trying to say out loud, Leanna, was if this is 2.5, I could do mental math. 18 plus 2.5, 18 plus 2 makes 20, or I'm sorry, a fourth, not a half, and a fourth, and you could do it like that. But then we ended up needing the 81/4 to make our answer simpler. Okay, so thank you for asking that. Let me show you one more. Hopefully this next one will make it nice and clear because this one will not have fractions, I promise. I'm also going to throw in a y, just so you can see that it doesn't always have to be x. Okay, so y squared minus 24y plus 23 equals 0. 23 is not a perfect square. I want to get rid of it. I subtract 23 on both sides. That's going to leave an empty spot in my third position, the C spot, empty. I'm now going to fill in that third spot by taking b over 2 and squaring it. Negative 24 divided by 2 is negative 12. Negative 12 times negative 12, 144. Before I move on, what do I need to do? I just added 144 on the left side. Jaden, don't forget, add 144 to the right side as well. Okay, so I've now forced the left side. Again, it has the minus, so this will be one with the minus. Y squared, the perfect square of y times y, 144. Perfect square of 12 times 12. Don't forget, when the signs are different, you need to subtract and keep the sign of the bigger digit. So we get 121. Now it looks like yesterday's work, hopefully. You recognize that? I take the square root of the left side and the right side. On the left side, that leaves my y minus 12 alone. On the right side, square root of 121 plus or minus 11. Final step, I add 12 to both sides. And now because again, it's just numbers, if it's positive 11 plus 12, one answer is 23. If it's negative 11 plus 12, that makes +1. There's my 2 answers. So I should have done that one first without the fractions. I know it's a little confusing to go back to an easier one. Hopefully not too hard. Again, the hardest part will be the fractions. Oh, computer went to sleep. Now, last thing I just want to show you, we're not going to do any more problems, don't worry, that's it. If you get a radical that does not simplify, say square root of 11 as an answer, just put the plus or minus in front of it. And let's say you were down to, you had x minus 4 equals 11, and you took, or x minus 4 squared, you took the square root, and you add 4 to both sides. You can just leave your answers with a radical. You can leave it as a radical. I don't need you to get 2 separate decimal answers for me. If you have an irrational square root, you can leave it in that form. Okay, now let my computer go to sleep.